Here's another good exercise that combines many of the materials you have learned so far. So earlier you built a program to convert someone's weight from pounds to kilograms. Now we want to extend this program and allow the user to enter their weight in either kilograms or pounds, and then we'll convert it to the other unit. Here's how our program is going to work. So I enter my weight in pounds, so 160. Now it's telling me, is this in pounds or kilograms? So here I need to enter L for pounds or K for kilograms. And by the way, this program is not case sensitive. So whether I enter a capital L or a lowercase l, it takes it as pounds. Now it tells me you are 72 kilos. Let's run this program one more time. This time I'm going to enter my weight in kilos. So 72 is the weight and the unit is kilograms, so K. And it says you are 160 pounds. So go ahead and spend a few minutes on this exercise. You will see my solution next. All right, first, let's ask the user their weight. So we use the input function, weight colon. We get the return value and store it in a variable called weight. Now the second question. So one more time, we use the input function, L for pounds, LPS, or K for kilograms. So let's get that too and store it in a variable called unit. Now we need an if statement. So if unit equals L, then we need to convert this weight into kilograms. However, with this implementation, we are only allowing the user to enter a capital L. If they enter a lowercase l, this code is not going to work. So this is where we use the upper method of string objects. So this unit is a string because, as I told you before, the input function always returns a string. So we can use the dot operator to access all its methods or functions. Here we call the upper method. This will convert whatever the user enters to uppercase, and then we'll compare it with a capital L. Now, if this condition is true, then we need to get the weight and multiply it by 0.45. However, as you know, this weight is a string object, and we cannot multiply a string by a floating point number. We talked about this earlier in this course. So first, we need to convert this weight to a numerical value. So right here, when we call the input function, we can get the return value and pass it to the int function. So we call the int function and give it the return value of the input function. Now, the int function will return an integer, so we can store it in this weight variable. So here's the converted weight. Let's store it in a variable called converted. Then we print. Here we can use a formatted string. So we prefix the string with F. We add curly braces to dynamically insert the value of converted variable. And finally, we add kilos. Otherwise, if the unit is kilogram, we need to divide the weight by 0.45. So once again, we type converted equals to weight divided by 0.45. And just to refresh our memory, this division operator returns a floating point number, but if we use double slashes, we'll get an integer. In this case, I want to get a floating point number. So finally, let's print a formatted string. Curly braces, converted pounds. Okay. Now let's run this program and see what happens. So weight is 160 in pounds, and that equals to 72 kilos. Perfect. If we run it one more time and enter 72 kilos, we get 160 pounds. In this tutorial, I'm going to show you how to use while loops in Python. We use while loops to execute a block of code multiple times, and they're often useful in building interactive programs and games. In a future tutorial, I'm going to show you how to build a simple game using a while loop. So let's get started with the basics. We write a while statement, and right after that, we type a condition followed by a colon. As long as this condition is true, the code that we write in this block will be repeatedly executed. Here's an example. We can define a variable like I, as in short for index, and set it to 1. Now, we set our condition to I less than or equal to 5. So as long as I is less than or equal to 5, we can print I on the terminal. And then we need to increment I by 1. So we set I to I plus 1. The reason we do this is that if we don't do this, I will be 1 forever. So we'll end up with an infinite loop because this condition will always be true. 1 is always less than 5. So in every iteration of this loop, we increment I by 1. So at some point, I is going to be 6, and then that is when this condition will be false, and then we'll jump out of this loop, okay? Now, to demonstrate how everything works, after this loop, I'm going to add a print statement, say done. So note that these two lines are indented, so they're part of the while block, okay? Now let's go ahead and run this program to see what happens. So take a look. We get the numbers 1 to 5 followed by done. So here's how this program gets executed. First, we set I to 1. Now Python interpreter executes line 2. This condition is true because I is less than 5. So I is printed on the terminal and then incremented by 1. Then the control moves back to the beginning of the while loop. So it doesn't go to the next statement. So we come back here. Now we are in the second iteration. In the second iteration, I is 2. And because 2 is less than 5, our condition is still true. So I will be printed on the terminal. And once again, it will be incremented by 1. So at some point, I is going to be 6. And that's when this condition will be false. So our loop will be terminated. And then this done message will be printed on the terminal. So this is the basics of while loops. Now let's make this program a little bit more interesting. Here we can write an expression like this. We add a string, and in this string we add an asterisk. And then we multiply this string by I. So with this expression, we can repeat a string. When we multiply a string by a number, that string will be repeated. For example, if I is 2, this expression will produce a string with 2 asterisks. Okay, now let's run the program and see what we get. So we get this little triangle shape here because in the first iteration, I is 1. So 1 times an asterisk produces 1 asterisk. In the second iteration, I is 2. So when we multiply 2 by 1 asterisk, we'll get 2 asterisks. In this tutorial, I'm going to show you how to use a while loop to build a guessing game like this. So we have this secret number, which is currently set to 9. Now the computer is asking me to make a guess. So let's say 1. It's not right because the secret number is 9. I can try again. 2. No, it's not right. Let's try again. So I only have 3 chances to make a guess. If I can't guess the number, the program tells me that I failed. Let's run the program one more time. This time I'm going to guess the number. So it's 9. There you go. It says you win. So let's go ahead and build this program using a while loop. All right, let's start by defining a variable to store our secret number. So we call that secret underline number and set it to 9. Now we need a while loop to repeatedly ask a user to make a guess. So while condition colon. What is our condition here? Well, we want to give our user a maximum of 3 guesses. So similar to the last tutorial, we can define a variable like I, set it to 0, and assume this represents the number of guesses the user has made. And then we can write our condition as I less than 3. Note that here I'm not using less than or equal to operator because with this condition, our loop will be executed 4 times while I is 0, 1, 2, and 3. So here we should use the less than operator. Now, if we give this code to someone else, it's not quite clear what does I represent here. It's only in our head that I represents the number of guesses the user has made. So as a best practice, always use meaningful and descriptive names for your variables. So it's better to rename this variable to guess count. Let me show you how to rename. So right click on I variable and then go to refactor and rename. Look at the shortcut. On a Mac computer, that's Shift and F6. Now in this dialog box, we can easily rename a variable and PyCharm will update all the references to that variable. So we don't have to manually update each instance, okay? Let's change this to guess underline count. Enter. There you go. Now that is better. Also, it's better to store 3 in a separate variable to make our code more readable because it's not quite clear what does 3 represent here. So let's define a variable called guess limit and set it to 3. And then we can change 3 to guess underline limit. Now our code is more readable. While guess count is less than guess limit, see, it reads like a story. This is how you should write code. All right. So while this condition is true, we want to ask the user to make a guess. So here we use our input function, guess. Now, whatever the user enters comes out as a string, so we need to convert it to an integer. So right here, we pass the result to the int function and then get it and store it in a separate variable called guess. So at this point, the user made a guess. Now we need to increment guess count. So guess count, we set it to plus equal 1. Okay. Now we need to check to see if the user made the right guess. So here we need an if statement. If what the user guessed equals our secret number. Again, see, our code is so readable. It's like a story. You can read it like plain English. So if this condition is true, we want to tell the user they won. So print you won. Now let's go ahead and run our program up to this point. So, okay, it's asking me to make a guess. I'm going to make the wrong guess. So 1, it asks me again, beautiful. 2, one more time, 3. Okay, what is missing in this implementation is the message that tells me that I failed. We're going to take care of it momentarily. But let's run the program one more time and make the right guess. So 9, okay, it says you won, but it's still asking me to make a guess because our while loop is going to get executed 3 times. Look, 1 and 2. So we need to change our program such that if the user makes the right guess, we need to terminate our while loop. We need to jump out of it. How do we do that? So over here, if the user makes the right guess, after we print this message, we can use the break statement to terminate a loop. When Python interpreter sees this, it's going to immediately terminate our loop. It's not going to evaluate this condition again. Now let's run our program and see what happens. So I'm going to guess the right number. You won, and look, we were not asked to make 2 more guesses. Beautiful. Now the last thing that we need to add here is the message that tells the user that they failed if they couldn't guess the right number. How do we do that? Well, in Python, our while loops can optionally have an else part, similar to the if statements. So earlier you learned that our if statements can optionally have an else part, like here. So if this condition is true, do this, otherwise do something else, right? In this case, our if statement doesn't have an else part. Now, similar to the if statements, our while loops, our while statements can also have an else part. So right at this level, we can add an else block, so else colon, and the code that we write here will get executed if this while loop completes successfully without an immediate break. In other words, if the user guesses the right number, we break this loop, we jump out of it, so the code that we write in the else block will not get executed. But if the user cannot guess this number, you're never going to break out of this loop, so this loop will be executed to completion until this condition becomes false. In that case, the code that we write in the else block will get executed. And this is the perfect opportunity for us to tell the user, hey, you made 3 guesses, but none of them were right. So print, sorry, you failed. Now let's test our program one more time. So guess 1, 2, 3. Sorry, you failed. Let's run it one more time. This time I'm going to make a wrong guess and then the right guess. We won, and our loop terminated immediately. All right, now it's time for you to practice what you have learned so far. So once again, we're going to build a game. This game is a simulation for a car game. Now, our game doesn't have a graphical user interface or GUI, and it doesn't really matter for now. Our focus is entirely on building the engine for this game. So let's see how this program works. When we run this, we get this little symbol here, and our program is waiting for us to enter a command. If we type help, either in lowercase or uppercase, it doesn't matter. We get the list of commands that our program or our game currently supports. So we can type the start command to start our car. We can type the stop command to stop our car, and quit to terminate the game. Any other commands that we type, our program is going to tell us, hey, I don't understand that. For example, if I type ASD here, it says, I don't understand that. If we type start, we get this message, car started, ready to go. If we type stop, it says car stopped. And finally, if we type quit, our program terminates. This is a fantastic exercise for you to practice what you have learned. So pause the video and spend 5 to 10 minutes to build this program. All right, we're going to start with a while loop with a condition. What is our condition here? We want to run this loop until the user types quit. So we can define a variable for storing the command that the user enters, and then we can run this loop as long as the command does not equal to quit. So right before the loop, we define a variable command, and initially we set it to an empty string. An empty string is a string that has no characters in it. We only have the quotes, okay? So then we type out our condition as while command does not equal to quit, then do something. Now immediately we have a problem here because we're assuming that the user types the command in lowercase. So if they type this in uppercase, our program is not going to behave properly. So to fix this problem, we need to call the lower method of the string object and then compare the result with this quit. We could also call upper and then type quit in uppercase. It's a matter of personal preference. In this demo, I'm going to use lowercase characters. So, okay. Now in this loop, we need to ask the user to enter a command. So once again, we're going to use our input function. We add a greater than symbol followed by a space. Whatever the user enters, we get it and store it in our command variable. Now, apart from the quit command, there are 3 other commands that we need to support: start, stop, and help. So here we need an if statement to compare what the user enters with one of the supported commands. So if command that lower equals start, then we want to print a message like the car started. So print car started, ready to go. It doesn't matter. Now the second condition. What if it's not start? Maybe it's stop. So elif command that lower equals stop. There you go. Then we print a different message, car stopped. Now look at our code. We have repeated this lower, lower, lower multiple times. This is bad. In programming, we have a term called dry, which is short for don't repeat yourself. So whenever you have duplicate in your code, that means you're doing something wrong. So how can we solve this problem? Well, instead of calling the lower method in each condition, we can call it right here when we get the input from the user. So this input function, as you know, returns a string. We can immediately call the lower method on that string. And with this, our command will always be in lowercase. So we don't need to call this method in every condition. Look, we remove the duplication, and also our conditions are shorter and easier to read. There's also one more place we need to modify, so it's right here. That is better. Now the third command. We need one more elif. If the command equals help, then we want to show the commands that we support. So here we're going to print a multi-line string. So we use triple quotes like this and give the user a guideline like this. So start to start the car, stop to stop the car, and quit to quit. Now finally, we need an else part. So if what the user enters is none of these commands, we're going to tell them, hey, we don't understand this. So else colon print, sorry, I don't understand that. And by the way, note that here, because I'm using double quotes, I can easily use a single quote as an apostrophe. Okay. So let's run our program up to this point and see what happens. All right, let's type start, car started, beautiful, stop, car stopped, help. We get this guideline, but there's so much indentation before our commands. We'll fix that in a second. And finally, let's test the quit command. Oops, our program didn't work properly. Here's the reason. With these if statements, we're comparing the command with start, stop, and help. Anything else will end up here. So that's why our program says it doesn't understand that. So that's why our program says it doesn't understand that command. However, after this else statement, the control will be moved to the beginning of the loop. At this point, our command is quit. So our loop will complete and the program terminates. In other words, when we run this program and type quit, our program actually quits, but we still see this message, which shouldn't appear here. How can we solve this problem? Well, we can come back here and just before the else block, add another elif, something like this. Elif command equals quit. Then we can immediately break. This will solve our problem, but note that we have kind of repeated this expression in two places. The reality is we don't really need this condition on the top because with these if statements, well, more accurately, with this elif, we can jump out of this loop and terminate our program. So we can simplify our condition to something like this. True. So while true means this block of code is going to get executed repeatedly until we explicitly break out of it. Okay. Now let's test our program one more time. So quit. Now our program terminates and we don't see that message. Beautiful. So let's fix the last problem. You saw that when we typed help, these guidelines appeared with so much indentation. And here's the reason. Look, right here in our code, they're already indented. So when we use triple quotes, what we type here will be printed exactly as is. So because we have indentation here, this indentation will also be printed on the terminal. So let's delete these. Okay, run the program one more time. Type help. The indentation is gone. Beautiful. Now here's a challenge for you. I want you to take this program to the next level. So right now, if we type start, we get this message, car started. And if we type start again, we get the same message. It would be better if we got a message like car is already started. So it doesn't make sense to start a car twice. Similarly, if we type stop, it says car stopped. If we type it again, we get the exact same message. It doesn't make sense to stop a car twice. So here's what I need you to do. If the car is stopped and the user tries to stop it again, the program should say, hey, the car is already stopped. What are you doing? And similarly, if the car is already started and the user tries to start it again, the program should yell at the user. So go ahead and make the necessary changes to implement this scenario. All right, to add this to our program, we need to know if the car is started or not. So there is one more piece of information that we need to store in the memory. What is the kind of data we need to store here? A Boolean. Is the car started or not? It's a matter of yes or no, true or false. So on the top, here we can define another variable like started, and initially we set it to false. So the car is not started, right? Now, when the user types the start command, here we need to check to see if the car is already started. If not, we'll start it, otherwise we'll yell at the user. So in this block, we write another if statement. If it's already started, then we print car is already started. Otherwise, so we add an else statement here. And at this point, we set started to true. So we start the car and print this message. Okay. Now we need to make a similar change for the stop command. So if the car is already stopped, we need to print a different message. If not started, so here we're using the not operator to see if the car is stopped. So if it's not started, that means it's stopped, okay? So if it's stopped, we print car is already stopped with double P's. Otherwise, so else, we need to stop the car. How do we do that? We set started to false. And then we'll print this message. As easy as that. Let's go ahead and run our program. So initially our car is stopped. So I'm going to type stop. It says the car is already stopped. So let's start it. Okay, now our car is started. Let's start it one more time. The program is yelling at us. So we cannot start the car twice. Beautiful. Now let's stop it. It says the car is stopped. Let's stop it one more time. We get this message again.